In this video, we're going to record calculations from molarity and dilutions that should have been covered in Chem 1. So with molarity, remember molarity is equal to the number of moles divided by number of liters. You do need to keep these units consistent. You cannot use grams and milliliters. So for example, we have concentrated ammonia that contains 26 grams per 100 milliliters of solution. What is the molarity of this solution? So since we need moles, we currently have grams of ammonia, so we have to change into moles. Remember, for molar mass, the ammonia is NH3. That's one to remember. So if we have 26 grams of ammonia, and we want to change into moles, the molar mass of ammonia is 17.034 grams. That gives us a total of 1.526 moles. And I'll worry about sig figs at the end. So moles is on top. We are going to divide by number of liters. So it told us we had 100 milliliters, therefore we have 0.1 liters. And do note that the decimal was printed at the end, so we need to be consistent with those sig figs whenever we count them. This is going to give us a molarity of 15.26, and molar is just capital M. So always refer back to your original numbers for sig figs. So 26 has 2 sig figs. 100 milliliters has 3 sig figs. So our answer should be rounded to 2 sig figs. So this is going to be a 15 molar solution. Let's look at another one. This time it wants to know how many grams of lithium chloride would you add to make a 2 liters of a 2.5 molar solution. So we know molarity, we know volume, and it wants grams. So remember, molarity is moles over liter. So we can plug in our molarity, our 2.5 molar. We don't know moles to get to grams, and our volume is 2 liters. So you can find out that we actually have 5 moles. We want grams, so change into grams using molar mass of lithium chloride, which is 42.391 grams, to give us 211.955 grams. With sig figs, 2 liters has 3 sig figs, 2.5 molar has 2 sig figs. So we want to round our answer to 2 sig figs. So we would make it 210 grams. Let's look at one solving for volume. These tend to be tricky. So determine the volume of 1.55 molar silver nitrate that contains 42.2 grams of solute. So remember, we cannot plug grams into a molarity equation, so we need to find moles first. So we have 42.2 grams of the silver nitrate. To change into moles, we need molar mass of silver nitrate, which is 169.88 grams, to give us a total of 0.248 moles. Now plug in what else we know. We do not know volume, and we know that this is a 1.55 molar solution. A lot of people mess up on these because they forget to take liters off the bottom. So you need to multiply by liters, and you end up dividing by the 1.55. So you figure out that our number of liters is 0.160 liters because we need 3 sig figs, or it could be written as 160 milliliters. If you write in milliliters, you still need to account for those 3 sig figs, so you would need to put a decimal at the end to ensure that it's 3 sig figs. Now on the flip side, dilutions. So remember, with dilutions, we're adding volume to change the molarity. If you look at these two images, you'll notice that the water level is different, but they're the same number of particles in there. So when we do a dilution, our number of moles does not change. Our moles we have at the beginning is equal to our moles we have at the end. If we remember, so with dilutions, we have molarity is equal to moles over liter. Well, if moles are equal, we can solve for moles and then put the two equations equal to each other to figure out our unknown molarity or unknown volume. So I just rearranged this to be that moles is going to be equal to molarity times volume. And when I have two different substances, or if I'm trying to perform a dilution, our beginning molarity and volume should be equal to our final molarity times volume. So our moles stayed the same. The only thing that's going to change is that molarity and that volume. So let's look at an example of a dilution. So remember our formula is that M1 times V1 equals M2 times V2. And here's our problem. It wants to know what volume of a 12 molar hydrochloric acid solution would be needed to prepare 250 milliliters of a 2.0 molar hydrochloric acid solution. So it's our same solution. We already said dilutions, we start with the same number of moles. The only thing that is going to change is the volume and molarity. So our beginning molarity is 12 molar. That's what it would actually come shipped from the company as. We don't know what volume of that 12 molar solution we need, but we know we want our final solution to be 2 molar, and we want to have 250 milliliters of it. You can leave it in milliliters, just understand that your answer will be in milliliters. If you change to liters, your answer will be in liters. So whenever you multiply 2 times 250, divide by 12, you get that our beginning volume is going to be 41.67 milliliters. Now to account for sig figs. 12 molar is 3 sig figs, 250 milliliters is 2 sig figs, 2 molar is 2 sig figs. So we want our answer to be in 2 sig figs.